Hi everyone, myself Sri Harshavardhan. I am studying in BTech first year in Srinivasa Ramanujan Institute of Technology from the Department of Computer Science and Engineering. Today I will explain about program on accessing structure members. Contents: Introduction of structures. What is a structure? Defining structures. Declaring structure variables. Accessing structure members. Initializing structure members. Using pointers with structures. Nested structures. Common use cases for structure. Best practices. Introduction to structures. Structures are user-defined data types that allow grouping related variables. They can store multiple data types in a single entity, unlike arrays. Understanding structures is crucial for effective memory management in programming. User-defined data types. You can already most a variety of Boolean data types with integers, strings, characters, and more. But often these limited data types are not enough, and a programmer want to build their own data types. Just as an integer is restricted to a whole number from 2.147.467648 through user defined data types have limit placed on their use by the programmer. A user defined data types is a feature in most high level programming languages which allows a user programmer to define data type according to his or her own requirements. There are two categories of user defined data types: non-composite data types. Another data types: composite. Non-composite data types are divided into two types: enumerated data type and pointer data type. Composite data type are divided into three types: record data type, set data type, objects and classes. Non-composite user-defined data type. A non-composite data type is defined without reference another data type. They don't combine different bulk in data types in one value. Non-composite data types are: what is a structure? A structure is a user-defined data type that groups related variables. It allows the combination of data types under a single name. Structures are defined using the struct keyword in C. Defining structures. Structures are defined using the struct keyword in languages like C and C++. A structure can include various data types such as integers, floats, and arrays. The syntax for defining a structure involves naming the structure and its number. See the program. Hash include stdio.h. Struct student details. Declaring structure variables. Once a structure is defined, you can declare variables of that structure data type. Declaration follows the format: struct name, variable name. You can also declare multiple structure variables in a single statement. Declaring structure variables. Define structure type. At the same time, declare structure variables. Struct tag name, data type member 1, data type member 2, semicolon. Close the brackets. Variable list. Struct student. List name, character name with size, character male, int age, float score, character address, semicolon. Accessing structure members. Structure members are accessed using the dot operator. For example, variable name, member name retrieves the value of a member. This allows for easy manipulation and retrieval of data stored in structures. Accessing structure members. You can access the individual members of a structure using the dot operator. The dot operator is called a structure member operator because it connects the structure variable and its member variable. The syntax is struct variable dot struct member, where struct variable is a variable of structure type, where struct member is a name of member variable of structure. Initializing structure members. Structures can be initialized at the time of declaration using curly braces. An example of initiation is struct name equal to curly braces value 1 value 2 semicolon. Proper initialization ensures that all members of the structure contain valid data. Declaring and initializing pointers. General syntax for declaring pointer variables. Data type, pointer name. Here data type refers to the data type of the value that the pointer will not 0. Int pointer semicolon pointer equal to address of x semicolon. Using pointers with structures. Pointers can be used to access structure members, enabling dynamic memory allocation. The row operator is used to members using pointers. This method is particularly useful in functions that modify structured data type. See the above diagram. Nested structure. Structures can contain other structures as members, creating nested structures. This allows for a more organized representation of complex data relationships. Accessing nested members use multiple dot operators such as outer dot, inner dot, member. Common use cases for structures. Structures are widely used in applications like databases and graphics programming. They help organize data logically, making code easier to understand and maintain. Common examples include representing coordinates, employee records, and more. Best practices. Always initialize structure members to avoid undefined behavior in program. Use meaningful names for structures and their members to enhance code readability. Be cautious with memory management when using dynamic structures and pointers. Conclusion. Accessing structure members is fundamental for effective data manipulation in programming. A solid understanding of structures enhances code organization and performance. Continued practice with structures will improve your programming skills and efficiency. Thank you.